Welcome to another fascinating RoboRAM education session. Today we will look at many sorts of CNC machines. Before we get into that, what exactly is a CNC machine? CNC machining is a production method in which factory tools and machinery are moved according to pre-programmed computer software. The method can be used to control a wide range of complicated machinery, including grinders, lathes, mills, and routers. Three-dimensional cutting jobs can be completed with CNC machining in a single set of instructions. Now, let's go back a few years. The first numerical control machines were developed in the 1940s when motors were used to control the movement of pre-existing tools. As technology advanced, the mechanisms were improved with analog computers and, eventually, digital computers, resulting in the advent of CNC machining. The great majority of CNC arsenals nowadays are entirely electronic. Ultrasonic welding, hole punching, and laser cutting are some of the more popular CNC-operated procedures. The machines that are most commonly utilized in CNC systems are CNC Mills. CNC mills can run programs made up of number and letter prompts that guide components across different lengths. A mill machine's programming could be based on G-code or a proprietary language developed by a manufacturing team. Basic mills have three axes, X, Y, and Z, while most contemporary mills can accept three more axes. Lathes. Indexable tools are used to cut components in a circular direction on lathe machines. Lathe cuts are made with precision and speed thanks to CNC technology. CNC lathes are used to create sophisticated designs that would be impossible to create on manually operated versions of the equipment. The control functions of CNC-run mills and lathes are similar in general. Lathes, like the former, can be controlled by G-code or a unique proprietary code. Most CNC lathes, on the other hand, have two axes, X and Z. Third type is plasma cutters. A plasma torch is used to cut the material in a plasma cutter. The method is most commonly used on metal objects, however, it can also be used on other surfaces. Plasma is created by combining compressed air gas and electrical arcs to achieve the speed and heat required to cut metal. The next one is electric discharge machines. Electric discharge machining, EDM, also known as die sinking and spark machining, is a process that uses electrical sparks to form workpieces into certain shapes. EDM uses current discharges between two electrodes to remove parts of a workpiece. The electric field grows more powerful and consequently stronger than the dielectric as the space between the electrodes shrinks. This enables a current to flow between the two electrodes. As a result, each electrode removes a section of a workpiece. EDM subtypes include the following. Spark erosion is used in wire EDM to remove parts of an electronically conducting material. Sinker EDM is a type of EDM in which an electrode and a workpiece are immersed in dielectric fluid for the purpose of piece creation. The detritus from each finished workpiece is carried away by a liquid dielectric, which appears once the current between the two electrodes has stopped and is supposed to eliminate any further electric charges, in a process called as flushing. And the last type is water jet cutting machines. Water jets are CNC machining tools that use high-pressure water jets to cut hard materials such as granite and metal. In some circumstances, the water is mixed with sand or another abrasive material. This method is frequently used to shape factory machine parts. Water jets are used as a cooler option for materials that cannot withstand the heat-intensive processes used by other CNC machines. As a result, water jets are employed in a variety of industries, including aerospace and mining, where the process is powerful for carving and cutting, among other things. Water jet cutters are also utilized for applications requiring very intricate material cuts, as the lack of heat avoids any change in the material's intrinsic qualities that could arise from metal-on-metal cutting. We hope you now have a better understanding of the many types of CNC machines. That's it for today's session, see you next time.